Dear students, welcome back to Blackboard. Today we are going to discuss the topic Revisiting Irrational Numbers. In class 9th, you were introduced to irrational numbers and many of their properties. You studied about their existence and how the rationals and the irrationals together made up the real numbers. You even studied how to locate irrationals on the number line. However, we did not prove that they were irrationals. Today we are going to prove root 2 is an irrational number. One of the theorems we use in our proof is our fundamental theorem of arithmetic. So let us recall, a number R is called rational if it can be written in the form a by b, where a and b are integers and b not equal to 0. A number S is called irrational if it cannot be written in the above form. That means a number is an irrational number if it cannot be written in the form a by b, where a and b are integers and b not equal to 0. Root 2, root 3, root 5, etc. are some examples for irrational numbers. So we are going to prove root 2 is irrational. In this section, we are using the theorem, fundamental theorem of arithmetic. One more theorem here we are going to refer, that is, let p be any prime number. If p divides a square, then p divides a, where a is a positive integer. That means if p is a factor of a square, then p is a factor of a also. Let us discuss it with the help of one example. You see 6 square. If 2 is a factor of 6 square, then 2 is a factor of 6 also. Now we are going to prove that root 2 is irrational. For this proof, we are applying the contradiction method. Means we are assuming the contradiction. Let us assume that root 2 is rational. We need to prove it is irrational. We will assume it is rational. If root 2 is a rational number, we can write root 2 equal to a by b, where a and b are co-prime and b not equal to 0. Co-prime means there is no common factor for a and b other than 1. Now squaring on both sides, if we square root 2 equal to a by b, we get 2 equal to a square by b square. Take this b square to left side, we get 2b square equal to a square. Keep it as equation number 1. Now we get 2b square equal to a square. That means a square is a multiple of 2. Means we can say a square is divisible by 2. If a square is divisible by 2, we can say a is divisible by 2 because in theorem 1.3 we discussed it. So if a is divisible by 2, we can write a equal to 2m. Any number divisible by 2 can be written in the form 2m for some integer m. So we can write a equal to 2m. Substitute a equal to 2m in equation 1. This is equation number 1. 2b square equal to a square. There a equal to 2m you substitute. We get 2b square equal to 2m whole square. That is 2b square equal to 4m square. Take 2 to right side. We get b square equal to 4m square by 2. That is b square equal to 2m square. Again we got b square is 2 into another number. So we can write b square is divisible by 2. If b square is divisible by 2, we can write b is also divisible by 2 by theorem 1.3. Here we got a is divisible by 2. Here we got b is divisible by 2. So we got a common factor for a and b. A and b are divisible by 2. Here we assumed root 2 is rational, so we wrote root 2 equal to a by b, where a and b are co-prime. Co-prime means there is no common factor. First we assumed a and b have no common factor, but here we proved a and b have a common factor, that is 2. We got a contradiction. This contradiction is due to our wrong assumption. What was our assumption? Our assumption was root 2 is rational. It is a wrong assumption, so we are going to correct it. Root 2 is irrational. Dear students, hope you all understood the topic. If you like this video, please like it, share it and subscribe it. Thank you, students.